brain fart here. So the output entity, I'm gonna say we take the exact same, yeah. Input entity, no. Okay. If last what do you say? And last input entity. Yeah, I think we can keep something like this. I don't think we've declared this yet, and that's okay. So first we need a position. And the position we want spawn the new entity is opposite the collision point. So that is like ooh, this is a little tricky. We have to save the collision result somewhere. So we can just have, yeah, this is what we can do. I think collision result is just an int. Yeah, it's just an int. So I'm gonna remove myself again.
Yourself again, Mike.
Yeah. And the correct file we are going to need is effect entity.h. Now we might not need an actual last input entity. I'm not sure yet. We do need the collision result. And we have to save that. I'll make the note 0 when invalid. Because collisions will always have, if there was a collision, it'll be a positive value. So for now we don't have to worry about the velocity. We'll just take the position. So that is a vector. Vectors are called filter vec3s. I believe they're structures. We'll call that one last collision position. you know what? We don't even need that. What we'll do in the middle of, so that it comes out of the middle of us with this entity. So what I'm saying is, if this is the effect entity, it doesn't matter if we hit here or here or here, we'll always spawn out of the middle. And I think that'll be nicer. I mean, it might make sense if someone collides way down here, that pops out also on the bottom. But the next time they tap this, it'll make more sense to pop out of the middle. And if it always pops out of the middle, it also makes sense. Later we might shape it to something more like a hexagon or something, or an octagon. Yeah, I need a drink of water. Where did I put my water? It's right here. Alright. Okay, so our entity now, we know what we have to do. We just have to calculate a position. And that's not so hard. Our position is just pos. And we have .x, .y, and .z. We also have a size. And the position is the central location. So actually, I bet that there should be a math function for this. Or we should at least be able to use math functions. So I'm gonna save this and make a new post. So what is this? Spit output. Okay, so let me draw the picture. We have a square, and this represents the effect. I'm not going to write it in the middle because I need to do stuff there. What we have mathematically to represent the structure is a single point, which is the position. And we also have, and this is a vector 3, so it has x, y, and z. We only actually use x and y right now, but we keep the z just because it would be that easy to convert to 3D. And what we also have a vector 3 called size, and it's just x, y, and z are not position. They don't refer to coordinates but the actual size. So this would be the x. It would be however big this is. And if the origin's here, for example, yeah, position's here, and then x, y, and z are like so. Alright, Sx for the whatchamacallit size vector. And in this case, I'll just look at the x. This, yeah, when you're doing whatever graphical like things, sometimes it's good to just do one vector, one axis. So this will be, this is 0, 0, 0, 0. This span is the px value. And all we have to compute, so for now I'm going to assume we collided on the left side and figure out how to get this value, because this is where I want to spawn. And I'm going to assume this entity has no size, or it's very, very tiny. But how do I spawn here, right here. Or sorry, right here. So you can see, I mean, just looking at this, you just take px and you add half of sx, and you'll get, because this amount here, once px drops off, is sx divided by 2. So we pretty much just have to look at the output of the what's it called? The collision result. And if we collide on the left side, we do this. If we collide on the right side, it's pretty much the same thing, except we subtract half of sx. Right, because this is also half of sx. And that would give us the left component. And we use the same y and z value. Yeah, and we don't have to worry about the size. We just take y and z position. So let's go ahead and do that. If there's not already some magical thing that does that for us. Okay. Yeah, so above we were doing yeah. I mean, I could do something cool and probably somehow shift and multiply to do this without a switch statement, but that would just make it really cryptic. So we're going to look at, what is it called? MLAS collision result. And yeah, we'll do a switch. I mean, this is the case that switch is meant to be. And we're going to take these. Oops. We're going to take this. Well, let me fix it. So there's going to be 4. And we can also just add the default here. Okay, so what are we going to put in the switch statement? Well,